Hi guys, today we'll be talking about process creation. How little baby processes gets created on our computers. How we can create new processes and make them do useful stuff. Let's get started. Before we understand process creation, we need to be sure about few terms. We need to understand what is a program and what is a process. Program is anything that you write. All the code that you write it as part of a program. But once you run this program, it gives birth to a process. I can have a simple hello world program and spawn multiple processes out of this hello world program. With this, we'll be able to create processes from shell, where we are running an executable and giving birth to a process. But can we make process from another process? Let me explain. And this is where fork system call comes into picture. You see, every process on Linux or Mac OS or any Unix based operating system is created using fork. When you boot up the system startup routine launches the init process, which in turn gives birth to multiple child processes to perform various system related tasks. These child processes can in turn create multiple child processes. So it is a big family tree and it's all about relationships between processes. So fork is a system call which instructs the operating system to create an exact replica of the running process. Let me explain how with an example. Here I have written a simple hello world program and added a fork system call just before the hello world. We can see there are two hello world being printed on the screen. To understand that, let me add one more attribute, that is process ID, in the printf prompt itself. We see each hello world is being printed by a separate process. How does that happen? When we are running the executable, as soon as sixth instruction is run, a new process is spawned that is replica of the exact same process. Now both of these processes run concurrently, each resulting in hello world on the screen. But isn't it waste of resources? We are doing the same thing in both the processes. We should be able to do two separate functionalities in the process. That is how we'll be doing something useful on the system, isn't it? For that, we need to capture the return value of the fork. Fork in the parent would return the child process ID, whereas in the child it would return 0. So I can enclose the return value of the fork in a if else and make decisions based on the return value. I'll be printing process IDs. Along with that, I'm also going to add the parent process IDs to be able to see the parent-child relationship between both of these processes. We can see both the process ID in the printfs. 4376 has been spawned from 4375 as seen in the second line print, where it says parent is 4375. That's all on fork. We'll be talking about exec in the next video, where we'll see how to load a new program in the child process.